Hi everyone. So today we're going to start with looking at standard form. So we had spent a lot of time talking about vertex form, picking out the vertex with H and K, and talking about the width and so on and so forth. So today what we're going to do is we're going to review that and introduce the other form, which is standard form. So it's kind of like y equals mx plus b is vertex form. When you get information right from the equation, you can get slope and y-intercept. And in vertex form, you can get the vertex and the width. Okay, in standard form you got to do a bunch of stuff to get there. It's kind of like going from ax plus by equals c and getting y by itself, then you get the information. That's kind of what standard form is. So I just want to take a minute and make sure we review our vertex form so you can see the relationship. So let's remember that vertex is y equals a times the quantity x minus h quantity squared plus k, where the vertex is h comma k. The axis of symmetry is x equals, shall we say, h. And the min and max is if a is greater than 0, it opens up and it's a min. Okay. If it's below 0 or negative, it opens down and it's a max. So let's put a star here saying, I think this is something that we definitely want to remember. Okay, so kind of keep that in mind. All right, so let's look at our subproperties in standard form. So here's our standard form. Y equals ax squared plus bx plus c. Okay, so these are the two forms. So we're going to start with our a, again, a being greater than 0, the parabola opens up. So that's familiar. And if a is less than 0, the parabola opens down. Okay, so remember down is a max and up is a min. So we'll make that note. All right, the x-coordinate vertex, now it's not going to be like we can just pick it out of the equation like we were able to do with vertex form. We have to go get it. So we have a little formula, and it's the opposite of b all over 2a. Where a and b is the coefficient of the x term, and a is the coefficient of the x squared term. Okay, so and then the y coordinate of the vertex is when we evaluate negative b over 2a. So we're going to put that answer into the standard form. The axis of symmetry line is going to be x equals negative b over 2a. And the y-intercept is always the c. Okay, so we could write it as 0c if we choose to do so. All right, so let's start with just being able to find that information, and then we're going to use that information to graph. All right, so let's find the vertex, the axis of symmetry, whether it's a min and max, and the y-intercept. All right, so the first thing let's do is identify who's a, who's b, and who's c. So you should be able to see that a is 1 because that's in front of the squared term. B is positive 2 because that's in front of the x. And c is positive 3. Okay, so we're going to find the x-coordinate of our vertex. I feel that's like really wide. No, that should be fine. All right, so our x-coordinate of vertex, x equals negative b over 2a. So, all right, so opposite of 2 or negative 2 over 2 times 1, which is negative 2 over 2, which is negative 1. Okay, now we're going to take that negative 1. We're going to take that and put it back in here for x, so we can find the y-coordinate. So y equals negative 1 squared plus 2 times negative 1 plus 3. Okay. So that's 1 minus 2 plus 3. So that's going to give us a y-coordinate of 2. Okay, so your vertex is at the point negative 1, 2. Okay, I feel like I wrote too big here. Okay, all right, now we need our axis of symmetry, which is the x-coordinate of our vertex. Remember, it's always a line, so it's x equals negative 1. It's a, the number in front is positive 1, so that means it's opened up, which means it has a min. Now our y-intercept is the c value, which is going to be positive 3. Okay. All right, let's try this one. So again, x, y, so x equals negative b over 2a. So negative 2 over 2 times negative 2. We're going to get a fraction here. So we're going to get negative 2 over negative 4, or positive 1/2. Now we are going to have to put that in. Okay, so we're going to get negative 2 times 1/4 plus 1 minus 5, 1/4, not 1/2. So that's 1/2, negative 1/2 plus 1 minus 5. I'm going to get negative 4.5. So our vertex is 1/2, negative 4.5. Okay. All right, and then we need our axis, which is x equals 1/2. A is negative, so it's below 0. It's less than, so it's a max. We know that opens down. And our y-intercept is negative 5. So we would have the point 0, negative 5. Okay, so we're going to need this information to do what we want to do when we graph. All right, so we want to be able to graph from standard form. And again, okay, we have that concept of, being able to pick that stuff out from vertex form. Again, we're going to have to do a little work. So we're going to have to find the vertex. Okay, so x equals negative b over 2a. Okay, so this tells you the x coordinate of the vertex. Okay, so we're going to plug the x coordinate back in, just like we did, into the equation to find the y value. Okay, we're going to plot and label the vertex on the graph, and then sketch our axis of symmetry. Remember, that's x equals the x coordinate, which we're finding negative b over 2a to get there. Okay, the c value represents the y-intercept. Okay, so plot and label this point and reflect that point over the axis of symmetry. That gives you 2 more points. And then you're going to need to pick an x value, find the coordinating y value, plot and label the point and its reflection. There's your last 2 points. Okay, and then we're going to play, connect your dots to form your parabola. All right, so let's do this one together. So the first thing, again, we're going to find our x, our vertex. So x equals negative b over 2a. So we're going to get negative 8 over 2 times 2. So that's negative 8 over 4, which is negative 2. We're going to find the y value. So 2 times negative 2, find these squared, plus 8 times negative 2 minus 1. So remember, you always, things that I see people do really bad math is that they don't square first. And squaring always gives you a positive number, right? All right, so this is 8 minus 16 minus 1, so that's negative 9. So our vertex is at negative 2, negative 9. Okay, which I believe is all the way down here. Yep, right there. Which means our axis of symmetry is x equals negative 2. So we're going to draw a vertical line there. There we go. Okay, and then our y-intercept is 0, negative 1. We're going to mirror image that across, so there we go. And you get to pick another point. It really doesn't matter what it is. I'm going to pick -1. Okay, and again, I always write way too big. Okay. All right, so -1 is my x value. Okay, so 2 times -1 squared plus 8 times -1 minus 1. So that's 2 minus 8 minus 1. So that's -6, -7. So over -1, down -7. Mirror across, and we have our parabola. There we go. All right. You want to do this one more time? Okay, so let's do this one more time just to make sure we're all on the same page. All right, we find our x equals find your y. Now be careful. Here I'm going to square first and then make it negative. So I got 6. So my vertex is at 2, 6. That means the axis is at x equals 2. My y-intercept is at 2. So I'm going to plot all that first before I find the extra point. Okay, so 2, 6. Y-intercept is at 2. Axis of symmetry is here. Okay, and I'm going to mirror image across. Okay, so far that's what I have. And then I'm going to pick another point. Again, whichever one, it doesn't matter what you pick. It really doesn't matter. You pick -1, -10,000. Keep in mind you're going to have to graph it though. So I'm going to pick just 1. So we use x equals 1. Okay, so -1 plus 4 plus 2. So that's 5. So I'm going to go over 1, up 5. Okay, mirror across, and plot my parabola. Okay. All right, so there's another one here for you to pause the video and try. All right, so why don't you go ahead and do that. All right, let's see how you did. So here's what I came up with. So hopefully that is what you got. All right. Okay, so the other part of this is being able to go from standard form to vertex form. All right, so we're going to need to do, again, this -b/2a, which is a theme for finding the vertex. So we're going to need that. All right, so if we're converting from vertex form to standard, from standard to vertex. So remember, that means that we're going from y equals ax squared plus bx plus c, and we're going to convert that to y equals ax minus h quantity squared plus k. Now, if we wanted to go the other way, we would have to write this twice and multiply, distribute the a, and then add k, which we're not quite ready to do yet. We'll come back to that later on in this whole unit thing. All right, so we're going to convert -x squared plus 6x plus 2 to vertex form. Okay? All right, so what we're going to do is we're going to find the vertex. Okay? Which means that we're going to do x equals -b/2a, and then we're going to evaluate to find y. Okay. All right, so let's come up here. So we're going to do x equals -6 over 2 times -1. So that's -6 over -2, or 3. We're going to find the y value by putting 3 in. So negative 9 plus 18 plus 2. Okay, I got 11. So our vertex is at 311. Okay. All right. So remember, that is your H and your K. All right, so this is H, this is K. All right, now what happens here is that the A value is the same as when it's finding the equation in vertex form of the graph. So in other words, the question I'm asking you is this guy the same as this guy in front of the squared? So we're going to find out if that's true or not. According to this, it is. I need to be able to say yeah or no. And then when we find that, we're going to plug the H, K, and A into our form. So how we're going to find A? Well, we're going to use the y-intercept, because that is the easiest point that we're going to be able to use with our quadratics. Okay? Because I can't use 0, 0. I don't know if that's on the graph. So I need a point that's on the graph. So my y-intercept in this particular problem is 0, 2. Okay? So I'm going to take my H and my K, the 3 and 11, and put them in for X. Put that in for H and K. So I'm using this form. I'm putting in the H, which is 3, and the K, which is 11. I'm going to put in 0 in for X, because that's the X coordinate of y-intercept. And I'm going to put 2 in for Y. Now I'm going to just do math. 2 equals a negative 3. 0 minus negative 3. 0 minus 3 is negative 3. Negative 3 squared is 9 plus 11. Okay, subtract 11. We're going to get negative 9 equals 9a. Divide by 9. Negative 1 is equal to a. Well, look at that. This is the same as that. Is that going to happen all the time? I think so. In fact, I'm pretty sure, but let's do a couple just to prove to ourselves. So now I'm going to put A, H, and K into the equation, and we have our answer. And that is the equation of negative x squared plus 6x plus 2 in vertex form. So y equals negative 1 times quantity x minus 3 quantity squared plus 11. All right, so let's try this one. All right, so we're going to find our vertex. We're going to find our y-coordinate. So our H and K, or our vertex, is 1, 6. So remember, this is your H and your K. Okay. Our y-intercept is 0, 5, and so that's my point. So y equals a x minus h quantity squared plus k. Okay, so I'm going to put in 5 for y, a, 0 minus 1 quantity squared plus 6. Okay, so 5 equals a, that's just 1 plus 6, subtract 6 is negative 1 is equal to a. And that's what we have there, so y equals negative 1 x minus 1 quantity squared plus 6. So really you only have to find the vertex. All right, so let's find the vertex here. Okay. All right, notice there's no x. So b here is 0. Okay, in this particular case, b is 0. So when I go to find my vertex, remember 0 in the numerator of any fraction is 0. We're going to put it into our equation. So we just get 3. So that means the vertex is at 0, 3. Here's your H, here's your K. So according to what we've been finding, the 2 that's in front of that x squared is the same as a. So we can go right to the equation. And you have y equals 2 times the quantity x minus 0 quantity squared plus 3. All right, try the next one on your own. All right, let's see how you did. Okay. I went through and did all the work and did see that the -6 that I found for a is the same as the -6 I found in x squared. So we can kind of assume, without doing a whole lot of proof or anything, that those are always going to be the same. All right, guys, let me know if you have any questions. If not, I'll talk to you again real soon. See you later.